In session 7, we have learned how changing the orientation changes the CDEF points, the concept of current entity in HyperMesh. In session 8, we are going to learn how to solve a fixed beam using 1D beam element, how to create multiple elements, and the concept of node A and node B. So first, let me show you the problem statement. So here is the problem statement. A beam of length 1000 mm subjected to a bending force of 30,000 Newton. The cross section is given here. The material properties are also given here, and the analytical solution is also calculated so that we can verify the results. So now, to solve the problem statement, let us go directly to HyperMesh. In HyperMesh, first I will select OptiStruct as the user profile. Click on OK. Now we are going to start with MHPCLL process. So first is material. Give a name to the material. Choose a color, type isotropic, card image as mat1 and click on create/edit. Here we will define E as 9.6 10⁴ and nu, that is Poisson's ratio, as 0.36. Now click on return and return. So material is done. Next is HyperBeam. So go to 1D page, HyperBeam panel. In standard section, select the standard section type as thin walled tube and click on create. Here we have to define the radius. So the outer radius is 25 and inner radius is 20. Now I will fit this to screen by pressing F from the keyboard. Now to go back to HyperMesh, go back to this icon. Now to exit the panel, click on return. Next we will create a property. So go to the property icon. Give a name to the property. Type as 1D, card image as P-beam, material as titanium, and the beam section as tube section. Now click on create/edit. Here I will enable continuation line 2. Here we have to define the CDEF points. So first is C1, which is 25, 0, 0. This is also 25. E1 is -25 and F2 is -25. Now click on return and return. Property is done. Next is component. So go to the component icon, give a name, give a color. In property, select the property and click on create and return. Next we will create nodes. So go to geometry page, nodes panel. Here we will create 3 nodes. So first is at 0, 0, 0. Second is at 500, 0, 0. And third is at 1000, 0, 0. Now if I fit this to screen, you can see we have 3 nodes. Now the reason why I have created 3 nodes here is because I need to apply force at the center, and the force is always applied on nodes. So we need to make sure there is a node at the center. That's why I have created 3 nodes. Next we will get out of this panel and we will go to 1D page, bars panel. Here we will go to bar 2 option. First we select the property, then we will select the element type, select the orientation. Now you have to select node A and node B. So select node A and node B such that a single node need not be selected as both node A and node B. A single node should be either node A or node B. For example, if I select the first node as node A and the second node as node B, now this second node is node B. So again I cannot select this as node A. It has to be node B. So that means this third node will become node A. And then this node will again become node B. So this center node stays as node B. Now click on return. Now we will remove the temporary nodes. Geometry page, temporary nodes panel and click on clear all and return. Now let's create load collectors. So I will go to load collector. First we will create SPC. Then we will create force as well. So force with a different color. Create and return. Once we are done creating this, we will go to analysis page, forces panel. Here I am going to select the node at the center. So if you are not able to see the node, you can simply click anywhere near the center and it will automatically pick up the node. You can see how it has picked up the node automatically. Now here I want to apply a force of minus 30,000 Newton. Negative sign indicates negative direction, and that is in y-axis. So click on create. Next, go to load collectors and make SPC as the current load collector. Now go to constraints panel. Select both constraints, that is node 1 and the last node, that is the third node. And for both of these nodes, I want to fix all the 6 degrees of freedom. So make sure all of them are checked. Load type as SPC and click on create. Now click on return. Now we have to create a load step. That is the last step. So go to load steps panel. Give a name to the analysis. In type, select linear static. For SPC, select SPC. For load, select force. Now click on create and return. Now all you have to do is save the file and solve the file. So to save the file, go to file, save as model. Here we will give the name as fix. Now to solve the file, go to OptiStruct panel, OptiStruct. Once it is done solving, go to results. First I will go to XY plane. Next we will go to contour and apply. So this is the result of deformation. Next we will see the stresses. So go to element stresses. So here we will take a look at the stress of SAC, which is coming as 5.176 10 to the power 2, that is 517. SAD, where the stress is 0. SAE, where the stress is negative, that is negative 517 e raised to the power 2. So now we are done with the problem statement. Now let me show you the homework. So for homework, you have to solve the same problem statement with different lengths and different magnitude of force and different cross sections. So these are the first 5 sets of problem statements. Next 5 set of problem statements for a total of 10 problem statements. You have to input these stress and displacement values in the table as shown here. Here you will have to calculate both stress and displacements analytically as well as in the software so that you can compare the results. So with this we have finished session number 8. Thanks a lot for attending session number 8. In session number 9 we are going to cover a problem statement on simply supported beam.